Hello there. In this video, I will show you a sample procedure which you can follow to set up a RAFT polymerization. As for the glassware and materials, I'll be using a 50 ml 2-neck round bottom flask equipped with a magnetic stir bar. You'll see one joint is sealed with a rubber septa. Below the flask is a glass flow control adapter with a glass stopcock which will be attached later to the second joint. For the reagents, I'll be using a methacrylate-based monomer, a trithiocarbonate chain transfer agent, or CTA, in a stock solution with a known concentration, AIBN, a thermal initiator, also in a stock solution, and finally, I'll be using anisole as the solvent for the reaction. First, I will place the flask in the balance and tare the balance. Once the readings are stable, I'll first add the CTA using a glass pastured pipette. The reason I'm using stock solutions for the CTA and AIBN is because I am adding relatively small amounts of each, roughly 50 milligrams and 2 milligrams respectively. Using a stock solution allows me to add the amount of each reagent more precisely. If you're working on a larger scale, or if you're less concerned with your relative amounts of each reagent, you could just add them directly. Next, I'll add the AIBN, which is also in a stock solution with a known concentration. You'll notice that after I add each reagent, I take a moment to write down the amount added into my lab notebook to keep a record. Next, I will add the monomer to the flask. One thing to keep in mind is that when you're adding the reagents, try to avoid getting anything on the ground glass joint of the flask. If you do, it's not a big deal. You can just use a chem wipe to wipe the joint clean. Lastly, I will add some additional anisole to the reaction mixture. Once all the reagents are added, I will seal the flask with the flow control adapter. Previously, I added a small amount of vacuum grease to the joint to create a good seal with the flask. Notice I set the stopcock to the closed position. Next, to degas the reaction mixture, primarily to remove oxygen, I will perform several cycles of freeze pump thaw. I will freeze the reaction mixture using liquid nitrogen and will give it a few minutes to completely freeze. Degassing can also be performed by bubbling with an inert gas such as nitrogen, which can often be sufficient and more practical in certain cases. The flask is now connected to a shrink line with rubber hosing. I will apply vacuum first by opening the stopcock to the vacuum line, which is connected to a vacuum pump. It's not on camera, but I am using a vacuum gauge to monitor the vacuum level during the freeze pump thaw process. Once the vacuum gauge reaches its minimum value, I will close the flow control adapter to the vacuum line. Then I will remove the flask from the liquid nitrogen and thaw the flask using a water bath. You'll notice that the dissolved gas in the reaction mixture will bubble into the headspace as the reaction mixture thaws. Once the mixture is thawed sufficiently and stopped bubbling, I will place the flask back in liquid nitrogen and repeat this process a few more times. Typically 3 or 4 freeze pump thaw cycles is typically sufficient to thoroughly degas the reaction mixture. On the last cycle of freeze pump thaw, I will close the flask to vacuum while the mixture is frozen and backfill the headspace with nitrogen. You'll notice the nitrogen bubbler will temporarily pause as nitrogen is introduced into the flask. I will then proceed to thaw the reaction mixture like I did before. After the mixture is completely thawed, I will then transfer the flask to a preheated oil bath. In this case, the oil bath is preheated to a temperature of 70 degrees Celsius. Do your best to place the flask in the center of your oil bath, that way that the stir bar stirs evenly within the flask. Once the flask is in the oil bath, you can monitor the reaction by taking samples and using techniques such as proton NMR to track monomer conversion, or GPC to determine molecular weight information. You can then quench the reaction once you've reached the desired degree of polymerization. That's all I have for this video. If you have any questions or comments, please leave them down below. And if you found this video helpful, please like and subscribe. Have a nice day.